Alright, this is the reassessment video for work energy. I'm going to do the same problem that we did in class. And we're going to have a box here that's being pulled with a tension at angle theta. We're going to pull a box M1, and there's a force of friction that we got to worry about. We're given that tension is 50 newtons, the force of friction is 13 newtons, the angle theta is 25 degrees. It's going to move 5 meters, the initial velocity is 1 meter per second, and M1 weighs 10 kilograms. That's its mass. So the first thing we're going to do is find the force, the x component of the force in the x direction. And we're going to do 50 newtons, which is the tension, times cosine of theta times 25, times cosine 25 minus the force of friction, which is minus 13 newtons. And we get the force in the x direction as 32.315 newtons. Now we're going to use this work equals force times delta r cosine theta equation to find the work. The work done is the force, which is 32.315, times delta r, which is 5 meters, times cosine of 0, since we found that this force was in the x direction, therefore it's the angle of 0. So that's just 1, and we multiply 32.315 times 5, and we get the work is equal to 161.575 joules. Now we're going to use this equation. Work equals the change in energy, and we know that change in energy is 1/2 mv final squared minus 1/2 mv initial squared. And the goal of this problem is to find how fast the box is moving after it has moved 5 meters. So plug in the work here, 161.575 equals 1/2 10 times, which is the mass, times the velocity final, which is what we're looking for, squared, minus 1/2 10 v1 squared. We're given v1 equals 1 meter per second. v1 is 1 meter per second. So I plug that in, and we get v1 equals 1, squared, which is 1, times 10, which is 10, times 1/2 is 5. So then we'll add that over to the other side to get it on the other side, and we'll do some simple math here. 1/2 of 10 is 5. So we know 5 velocity final squared equals 166.575. We'll divide both sides by 5, take the square root of both sides, and then we get final velocity is 5.77 meters per second.